We are rolling audio, and we are rolling camera 1.
Running camera 2.
These guys are so soft-spoken. All right, who are UCI? Who are my subjects?
I'm Angela Rigdon.
Veronica Berrocal.
Good thing I didn't say I do Spanish. All right, here we go. Take 1.
Why, thank you. To begin with, could you introduce yourselves a little, which will save me a lot of mispronunciation?
Sure. My name is Angela Rigdon.
Yeah.
I'm an assistant professor in Earth System Science.
Okay.
Yep.
And you?
I'm Veronica Berrocal, and I'm a professor in the Department of Statistics.
Yeah. Okay, and can you tell me a little bit about this project that you're working on together?
Sure.
Just to bail right into that, if
Yeah.
you would. Okay.
So this project is about mapping drought in California, and it's specifically looking at drought by understanding how much water is evaporating from the land surface to the atmosphere. And the project brings together lots of different data sets and process-based models, and it also brings together, it kind of has a statistical underlying, which Veronica can talk more about. But
Okay, and how does this differ, what you're working on, from previous ways of trying to determine drought effects? And is it predicting droughts at all, or just saying where things are headed?
I would say we're mostly monitoring drought as of now, but the word drought itself just means that there's less than normal water. And so you can define drought using lots of different hydrologic variables. I think the most common when people think there's a drought is they think, oh, there's less precipitation, there's less rainfall happening in California. But what our project is doing is defining drought in a different way. Rather than looking at how much water is input into the system from rain, we're looking at how much water evaporates. And that's a kind of a new way of doing things because we haven't had those measurements of evaporation for decades like we have precipitation.
Right. Okay, and how are plants involved in determining that amount of precipitation, or how it's held on to?
Yeah, so should I keep going? Okay. So when we're talking about defining drought based on how much water is evaporating from the surface, the water can evaporate from the soils themselves, but it can also move through the vegetation. And so the plants are pulling up water through their roots and evaporating it off their leaves, which is called transpiration. And that accounts for, it can account for over half of the water that's moved from the land surface into the atmosphere. And so what we're trying to do is understand how much water is evaporating, or not understand, we're trying to quantify how much water is evaporating from the land surface. So that includes soils and plants. And we want to understand it from a drought perspective, which means we want to know, is it more or less than, quote, normal? Because that's how drought is defined. Is it more or less than normal?
Okay, how do you set the baseline for normal?
This is the big question, is how to set the baseline. And it's a hard question because you can set a baseline for precipitation more easily because we have really long records. We have 100 years of rain gauge data. People would go out and put cups and measure how much it's raining. But measuring evaporation is really technical. And so we only have, I would say, like high quality daily or sub-daily measurements of evapotranspiration since like the late 1990s, early 2000s, not a lot of them. And so to set the baseline, we're gonna use basically a physical model that looks at the atmosphere and says how much water must have evaporated for the atmosphere to have this particular state. Yeah. So we're using a physical model.
Okay, and how are the plants measured? Is it done by satellite or something, or?
Yeah. So what we're doing is we're measuring. We're gonna try and piece together a record of evapotranspiration, and we have some sites that are actually measuring. I would say the most direct measurements are from these instruments called eddy covariance instruments, and what they're doing is they're taking really, really high frequency measurements of water vapor moving as it moves up and down in the atmosphere. And using these high frequency measurements, they can infer how much water vapor is basically leaving the land surface. And so we get this like ecosystem level flux of water as it moves from the land surface into the atmosphere. Those are like the gold standard measurements.
Okay.
And then we're going to use a lot of different other measurements to kind of take those in situ site level gold standard estimates and scale them across California. And to do that, we'll use physical models and we'll use remote sensing, so images from satellites.
Okay.
Yeah.
Thank you. And where does being a statistician play into this?
Well, so all these data sets that Angela has described, they are characterized by the fact that they are relating to different, even though they're trying to capture the same underlying quantity, they're probably obtained through different modalities. So they have different amount of uncertainty. They also have different spatial scales. So statistics comes into the play because we are trying to get this data to the same spatial scale and also accounting for the different nature of the data and quantifying the uncertainty in the estimates of evapotranspiration and drought.
Okay. As a statistician, do you work a lot with the other schools and departments of the university? I would think so. But
Yes, I work mostly with faculty, with Angela, faculty in this school, and then with, I have a collaborator in the School of Public Health that also looks at environmental factors and the relationship with health. Yes, but I also have collaborations outside of UCI.
yeah. Yeah, collaboration hasn't always been the thing at universities so much. Like in the old days, we were mostly pouring hot oil from the parapets on each other, given the option. Do you sense like there is a lot more collaboration these days, and what do you think is driving that?
Well, for statistics, I think we are innately very collaborative because unless you do more theoretical statistics that is very similar to math where you can be working by yourself. Typically, we are looking for helping other scientists to provide answers to their questions, and so we're really developing methods to answer scientific questions. So it's very typical for statisticians to collaborate with people across different fields.
Yeah. So you just don't get to sit there and play with abstract numbers all day.
Yeah, no, I think it's a small number of people that do that. More and more there is a great interest in collaborating, and also, it's important that you work with somebody in the field to understand the data that we have in front of us, because just downloading a data set from the internet doesn't tell you what is the measurements, how the data have been collected, what are all the different, issues of potential bias and other issues that are in the data. So it's important that you talk to the person in the field to understand all the nuances of the data.
Is it your impression that there's more collaboration these days, or am I just wrong on what the past was like?
So I'm also I feel like I'm very collaborative, and maybe it's just from my perspective, but like when I came to UCI, within the first 6 months, I had Veronica emailing me saying, I read one of your papers, I would love to talk about it because I think one of the assumptions can be relaxed and we can fit a Bayesian model to it and understand these processes better. And so we've been working together for 3 years on numerous different projects. And I also study plants, and so I've worked with plant physiologists because even if I'm taking remote sensing images and I'm looking at the plants, I want to make sure that I'm understanding the physiology. And so talking to someone who's actually out there measuring the fluxes of water as they move through the trees and out of the leaves, like that's invaluable to me. And so like I've written papers with statisticians and plant physiologists and agronomists, and so I think collaboration is essential for my work.
That's good. Do you spend much time in the field? And what is the field out there?
So like I spend a lot of time in the field of data.
Okay.
I look a lot at remote sensing and remote sensing. So I don't actually spend time in the field. No. Yeah.
Okay.
There are people out in the field who have dedicated their careers to understanding how to take measurements really accurately and precisely, and I respect them, and I work with them and email them, and we talk about data. But as much as I want to go out and measure how much water's in the soils, they're doing a great job.
Okay. And how is measuring the way that plants are dealing with precipitation, like what's passing through them, waterways, how does that change the picture of things?
Yeah. So the cool part about looking at evapotranspiration as a drought index is that it's capturing how much water is available on the land surface, and it's also capturing how the atmosphere can evaporate that water, so the demand for that water. So if the atmosphere is really hot and dry, it can evaporate water really quickly. That's why you use like a blow dryer on your hair to evaporate the water quickly. If there's a lot of moisture on the land surface, it has water to evaporate. And so what you're capturing by looking at evapotranspiration is you're capturing both how much water is there and how efficiently the atmosphere can evaporate it. And so it's different from precipitation, because precipitation is just the input of water into the system. If I say it rained 10 inches this year, let's say this week, there's a big difference of it raining all in one day or raining a little bit every single day. And so this kind of like looking at evapotranspiration gives us a better picture of how water is being used at the land surface.
Okay, do plants that retain water better, are those what are called drought resistant? And is there an advantage, I guess, to having more foliage that retains water?
Yeah, there's different drought strategies for plants. And so, yeah, if you're a drought, there's different plants have different strategies when there is a quote drought. So let's say when there's lower than normal moisture in the soils, different plants will react differently. I don't know how much you want me to get into the biology of plants.
Okay, and would there be a future in like planting various species of plants in various areas to help resist drought in those areas?
Yeah, well, the thing about drought is, like, let's say that there's a drought in California, which we hear a lot. If we looked at evapotranspiration over much of the Central Valley, it would not look like there's a drought, because farmers are pumping groundwater and irrigating the plants, and there might actually be more evapotranspiration because the atmosphere can evaporate the water quickly, and there's enough water on the land surface. And so human management and farmers' decisions are also playing into whether or not the land surface is actually experiencing drought. And so your question about plants, I would like the first kind of thing that goes through my mind, or are we talking about agricultural plants, or are we talking about like natural ecosystems?
Yeah, well, let's take each separately, I guess. Is there any point or way of convincing farmers what to raise from an ecological standpoint, or is they just what's the most profitable for them to raise at any given time?
Yeah. I'm not sure I'm the person to answer that. Like,
okay.
Yeah, because one thing that I think is really cool and that I'm thinking a lot about now is the difference between shallow-rooted plants and deeper-rooted plants. Because if you're a deeper-rooted plant, you can access water that's below the ground, and that is a drought strategy. And so, so that's one thing that I'm kind of thinking about.
Yeah. Okay, and for areas that are, say, adjacent to human habitation, is there any any future in like just changing the plant formations around where people might be living?
I think it's less about. I mean, it maybe could be changing natural ecosystems, but when I'm thinking about monitoring drought or monitoring evapotranspiration for natural ecosystems, I'm seeing it more as a way to quantify risk and understand how dry the plants actually are. Because the amount of water, if they're transpiring a lot, it means that they have access to water. And if they're not transpiring, it means that they have no access to water. And in California, that means it relates a lot to fire risk.
Okay.
And so we're thinking about fires and how we could use this drought index to help inform fire risk.
Okay, ultimately, what do you hope would be the outcome of your studies in terms of how they affect the science of things going ahead in the future of determining what we're going to be doing about drought,
Yeah.
if anything? So,
I think me and Veronica working together,
Yeah.
we can take a lot of distinct data sets and merge them together in a way that is statistically robust and come up with estimates of evapotranspiration drought with uncertainty bounds, which is totally like
Yes, it's very important.
really important. And without this collaboration, I would be like doing the statistics way more naively, and I probably wouldn't get the. And so what I want to come out of this is this really cool product, and I shouldn't say really cool. I should say really accurate product.
I think the implications then really, like what people will do with this product will depend on a lot of factors, like decisions are not just based on one input. There is a whole suite of factors that you need to take into considerations, So I think just having this product with this uncertainty quantification will be very important, because when you take decisions, how reliable your estimate is very important.
Yeah.
And so having that measure is actually going to be extremely important. Then we cannot predict what decisions people will take, because, as I said, there are a lot of factors that come into play when people make decisions. It's not just one quantity that will determine what decisions are taken.
what was it about Angela's paper that attracted you to it, that you thought you could have some input there?
Yeah, so I have worked a lot in air pollution during my postdoc and during my first years as an assistant professor, and I wanted to still work in environmental statistics, but I wanted to expand my horizon to other aspects of the environment. And so just before I met Angela with a student, we started to look at soil organic carbon, and I got very interested in soil. And so I thought it is a place where there is maybe a good possibility for statisticians to make a contribution, because not many statisticians at the time that I was aware of were working in soil. And so when I came to UCI, I met a faculty here, and I was trying to establish a collaboration. And he told me about Angela that was joining UCI, and that she was probably the right person for me to connect to. And so he told me that Angela had this paper, and I read the paper. It was very interesting because it was looking at in her paper there were many open problems from a statistical perspective that I got very excited about. The nonlinear relationship between agricultural yield and different atmospheric and soil inputs. And so I was really intrigued by that. And when I read Angela's paper, I thought there are many things I can contribute and help you with here that I think it would be great if we could work together. And Angela was very open to it.
Mm-hmm.
Okay, could you tell me what led you to study this? I mean, your long term, where did you start in education, and what led you here, I guess?
Yeah, so I would say I've always had an appreciation for nature, and so when I was an undergraduate, I started doing research in a hydrology lab, and I was out in the field actually taking measurements in wells and testing water quality for agricultural runoff. And then I quickly learned that I love modeling things on the computer as much as I love nature and being outside and hiking. I like to do things, make models. And so, it started with undergraduate research, I would say, for me. And I've just been kind of riding that wave ever since in
Okay.
hydrology.
Okay, and where would that have been, and how did you wind up at UCI?
I did a PhD at Boston University, and and during my PhD, I focused almost entirely on building physical models of how to estimate evapotranspiration if we don't have those fancy eddy covariance instruments. So if we look at a weather station measures temperature, humidity, wind speed, precipitation, air pressure. How can I take those 5 variables and estimate how much water is evaporated? And that was my whole PhD. And then I went to Harvard University and I did 5 years of a postdoc where I kind of learned more about agriculture and how I could take what I know about the physics of evaporation and apply it to something more, I would say like more societally relevant and more kind of like more applied. And so that's my background.
Okay, and what brought you here?
So I was a faculty at University of Michigan in the School of Public Health, and I've got my PhD in statistics. There I was in the Department of Biostatistics. It is a little bit different, the focus, and I felt I wanted to go back to a purely statistics department and not be necessarily in a biostatistics department. So part was that, part I was ready for a change of scenery, and the Department of Statistics here is not as old as maybe the Department of Biostatistics, University of Michigan, where I was, but it actually has a great reputation. And so, California, a very nice department, so it was all, I think, a win.
It seems funding universities everywhere now is vanishing. How does that affect you? Does it make it more of an interesting challenge and finding new ways of still getting stuff done, or what does one do when the money runs out? Yes. Does collaboration help find paths around that to get stuff done still, or?
I don't know how to answer that question.
Okay.
I mean, I'm an
even
assistant
know how to
professor.
ask
I've
it.
been here for 3 years,
Yeah.
and so I don't know if that's long enough to have ever experienced a really vibrant funding atmosphere. So this has been this is my norm. Yeah, my work I use a lot of public data. All of NASA's data is publicly available.
Yeah.
My work, my students can answer really good questions without funding, but they just can't do so at a capacity well, I don't even know if that's even true. They're still doing awesome.
Yeah.
But funding would allow them to focus on their work, right?
Well, I mean, yes, funding affects many things, right?
Yeah.
The number of students that you can admit in a program, so that means less help to get your projects done. As faculty, we have a lot of demands, we have teaching to do, and so having help in research is really important. And if you have less students that you can rely on, the progress of research is really slowed down.
Yeah.
And in terms of funding, I think the fact that there is less funding available means the competition is really, really hard. And I guess maybe the pressure produces diamonds. I don't know. I guess the more pressure you have, the more interesting research ideas people have to put out. I don't know. That's if you want to find some, silver lining.
That's a great attitude. It meets covering your head and running, which would seem to be a realistic outcome sometimes. I guess what would the outcome be of your research? I mean, how would it affect things?
So
I
if
don't
this
know.
specific project,
Yeah.
I think that, we're working now to engage with people who are making decisions. And ideally, I would love if we could build a product kind of from our perspective, and then we could find a water manager, an irrigation district, fire, if we could find a group to help us build our product kind of in collaboration, and that's the goal. It's so that it can actually be used. But while we're still developing those relationships with end users, we're focused on getting the science right, curating the data, combining it in a robust way.
It's also very difficult to be able to communicate research results to the general public. When I was a PhD student, my PhD advisor had this very large grant funded by the Department of Defense that was focused on taking these weather forecasts that computer models generate and basically correct them for potential errors, but also provide uncertainty around the estimates, So this is how you get probability of rains and things like that. But then it's very hard to communicate this to the general public, because if you give uncertainty, people might taking it as, oh, you don't know what the weather is going to be like. And so in the team, we had a sociologist that was basically helping us understanding how to communicate the results of our research in a way that was more easily understandable to the general public. And I think in biostatistics department in the School of Public Health, there is a lot of that going on where, researchers conduct the research, then they think about how can we communicate what we have found to the general public to help, right? And I think for a research like the one that Angela and I are doing, there will be eventually also a need to think about how do we communicate what we have achieved to the decision maker in a way that they can get the best out of the product that we have created.
Excuse me. Ideally, does this change has vegetation been included in studying precipitation and drought most of this time, or is that kind of a newcomer to the equations?
I think that there's lots of different ways to define drought. And so if you go and read about drought in a textbook, you'll see there's different types of drought. It's been defining drought based on how much water is actually evaporating is really hard. And so that is new. But not to say that we're the only ones working on it. But this kind of framework of using evapotranspiration to define drought is, with uncertainty and combining the different data sets, I would say is exciting.
Mm-hmm. Okay. Yeah, something that's new in not exactly new in some of the sciences dealing with humanity and what we're all up to is sending, canvassing areas where you actually send out and you ask the people living in a particular neighborhood how the weather affects them, how this affects some other things. Is this sort of like the vegetation version of that? We're asking plants that live in an area what they're thinking of it? Not that plants are particularly more sentient than I am, or less, but
that's exactly right, though.
Yeah,
I have this dream of using plants themselves as the sensor. Mm-hmm. So using vegetation as the soil moisture sensor, because you can imagine where maybe we don't know how much water is meters below the surface. Yeah. Most measurements of how much water is in the soils is in the top 10 centimeters, 15 centimeters. And so using the plant as the sensor is kind of the whole heart of the project. Okay. Yeah.
And you're developing a lecture on this?
I'm developing a course next quarter that's about using remote sensing to understand plant water stress. Because with satellite instruments, we actually can't measure how much water is evaporating, because the evaporation is a flux of water. It's the movement of water, but we can measure how hot they are. And a plant that is hot tends to be more water stressed than a plant that's cooler, because evaporation cools the surface of the leaves just as it cools your skin. And so that's how you can use remote sensing to estimate plant water stress and evapotranspiration, is by measuring slight variations in its temperature. What's cool about the class, I think, is that I think it's an opportunity to bring together people from plant physiology, because they know all about leaf and how leaves, the energy balance on the leaf surface, which is complicated and it's its own field. Remote sensing, so engineering, because they're the ones building the sensors and building the algorithms to actually get the temperature of the leaf. And then Earth System Science, which is my department, because we're using the temperature data to understand processes. And then statistics and informatics, because they're also understanding the uncertainties with all of these algorithms and data sets is essential to using them. And so I'm hoping that we bring together lots of people in the class and have vibrant discussions.
Okay.
Yeah.
And I assume understanding the part of the statistics play in this as well would be part of the course?
Yeah, Veronica's going to give a guest lecture about
Yes.
about combining different data sets, and
Yeah.
it's going to be fun.
Okay. Any future projects in the shoot that you're thinking of?
Any future projects of
Like beyond this, other directions you want to examine and. Yeah.
we have some other projects that we're working on now. Do you want to share some of them, Veronica?
Are they secret?
Are they secret?
Yes, I don't know.
Yeah. Well, no, they're not secret. We're just. I'm trying.
It's up to you.
I'm trying to think of how to frame what we're working on. You can do. You can.
No, you talk.
Come on.
And don't worry, we have lots of power of editing, so.
I know.
Yeah,
Like,
none of this, are we gonna do stuff? That won't be in here.
okay. I'm trying to. Yeah. I mean, we have lots of projects, but we just. I don't know
Yeah,
which one
I
we
don't
wanna talk
think.
about.
Yeah, I don't think you should
Yeah.
talk about it.
Yeah.
Okay. If this plant could talk, what would it be telling us?
It needs water.
It needs
Yeah.
water. Yeah.
Okay.
Yeah.
Okay. I'm
And
sure
maybe it
there's-
gets too much sun.
Yeah.
I think this is too much sun for this plant in this room.
Yeah. Okay. Well, thank you, Mr. Plant. So what have I neglected to ask you so far?
I don't know.
That's always a good one.
Yeah, no, I think you've asked a lot of interesting questions.
Yeah.
Is there anything wrong? Is there anything that you think? Did I say anything wrong?
No.
Okay. Has any of the data or what you've arrived at from it surprised you at all?
Oh, you didn't mention the part of Josh.
Oh yeah, I should mention we have someone we're working with, a partnership.
Oh,
We
is
should
that-
talk about that.
Okay, is that the gentleman Chapman?
Yeah, he's a gentleman at Chapman, yeah.
Okay.
And yeah, so we're working with a company that's putting instruments into space. They're kind of low-cost thermal instruments, so they're measuring temperature, land surface temperature, at a really high spatial resolution. And the company's called Hydrosat,
Okay.
and we're going to be using their estimates of temperature, water stress, evapotranspiration in our drought maps.
Okay.
Yeah.
How is working with an entity that's outside of the field of education? How do you do that with like combined business and education? And
Well, the great part about that is I will learn how to best do this. And so, yeah. How do we do it? TBD,
okay.
right?
Fellows, any great ideas I should ask? No?
No, I think it's
No.
great. Yeah.
This might be close to it.
Oh,
Okay.
good.
You know?
Yeah, is there anything? Okay, cool.
I guess I'd like to have a little more background on you, like where were you educated initially and where'd you grow up and
Yeah.
and was it someplace where you had a lot of nature around or?
Yeah, I grew up in Missouri. Yeah, and I had a lot of nature around. Yeah, so I was like going to the creeks and hanging out outside all the time. Yeah, so I had a lot of nature around.
Right. And you?
I grew up mostly in Italy, in a small town south of Tuscany. So I also grew up in a place with a lot of nature. Used to do mostly things with my bikes and walking, not much use of transportation or things like that. So I also was very interested always in nature and environment.
Okay. How would you compare Irvine to Tuscany?
There are some things that are no
little
Irvine,
different?
not necessarily Irvine, but like if you drive out, there are some things that are very mindful of, central Italy.
Mm-hmm.
Yes.
Yeah. Okay, that might be it. Wait, you, mister?
What's your favorite color?
Orange.
Yeah.
What?
Yes.
Yeah.
Jim's
I thought
wearing-
nobody liked orange
Jim's
through the
wearing a
last
shade.
8 years.
Yes. No, I'm a big orange and red fan.
Yeah. This is my go applying for a job suit. It hasn't worked yet.
Have you
So-
figured out how sarcastic he is yet? So all we want to do maybe is get their bio. We'll do the individual.
Yeah.
The
Okay.
bio?
Yeah.
Yeah, so we'll shoot each one of you individually. So I guess we'll cut this for now. So
Okay.
I'm going to say cutting for now.